Welcome to the future. Make sure that for this video, when you watch it, you fully open your work, you add full explanation and full working out calculations when necessary, and make sure that you're awake because we need to do these three things. 1, 2, 3. Again, the explanation, we need to know why or describe, and calculations, we need to know the equations and how to use the equation. Let's get started. Now, this is the equation. This is the question about the graph, velocity, and time. Okay. Now we can actually see that the graph starts at this point here, which is 14. It goes all the way to this point, which is here, 26. Now you can easily discount the squares to get there. We need to work out the acceleration. Again, acceleration in the first 34 seconds. 34 seconds is here, so this is 34 seconds. Now, how can we do this? First of all, we need to remember that to get the acceleration from this graph, we need to work out the gradient. Okay, and how do we work out the gradient? The change y over change in x. So the change y is the velocity, the change velocity, which is 26 and 14. So therefore, it's going to be 26 minus 14 divided by the change in x. So the x is from 0 all the way to 34. So therefore, this is going to be 34. Now, we have this. So therefore, we use calculator 0.35. Okay. Now, you talk about significant figures there. Now, normally you will learn this in maths, and then this will be and this will be better. But what does this mean? It means that we need to look at. So instead of writing decimal points, let's say whatever we have decimal points, we're going to write it to an appropriate number of significant figures. Okay. Now, you must going to learn this, but normally we're going to write it to two significant figures because we have one figure here and then we have one figure here. So this is two figures. Now, why do we choose two figures? Because if you look at the number in the questions, this number here in the question, so this one is one figure and this is two figure. Okay, so therefore we want to write the answer close to two significant figures or two decimal points in this case. Yeah, but don't worry about that. Okay, you're not going to be penalized yet because you have not learned this in maths, and maybe so normally for A level this is where it becomes more much more, but when you learn about it, all good. Now we have distance. How can we work out distance? Now again, if you remember, distance will be the area under the graph, okay. Now what area do we have under the graph? The area we have, so from here we go down. Okay, so this whole area, so I can see that I have a triangle number 1 and I have a rectangle number 2. So you need to show that you work out the area. So therefore it's going to be the area of the triangle plus the area of the rectangle. Now the area of the triangle would be half multiplied by base. The base is 34. How do we know the base is 34? Look, the base is from here all the way down here. So therefore it's 34. Okay, it's 34 seconds, 34. And the height is from here to here. So the height is from 14 to 26. So therefore it is going to be 12. So therefore the height is multiplied by 12. Put in brackets to make it all nice, and then rectangle. How do you work out the rectangle? It's going to be length times width. So the width is 14. So this is 14, and then the length is 34. So therefore 34 multiplied by 14. Okay, and then we're going to get 680. 680. Now it's 3 marks. So what we need to see that, okay, do you know it is the area? Have you worked out the proper area, and do you get the answer in this case again? So this is the full working out, full calculation there. Now let's take a look at this one. Now we want to work out here, describe an experiment, describe an investigation experiment. What experiment can we do to show that the speed of the falling cupcakes depend on the number of cupcakes? Now first of all, we need to work out the speed. So therefore, and it's falling. So therefore, what do we need? Okay. So therefore, we need what? Okay. So first of all, I'm going to start with number 1. Okay. You know what? Let me just use number 1 there. So make it easier. So number 1. So speed equals distance divided by time. Okay, that's the first one. Now the second one is how are we going to get distance? So distance, how are we going to get that? Now remember, we're doing an investigation. So distance, we're going to say measure. Okay. So again, we're forming it. So measure the distance, measure the height. Okay, measure the height using a ruler or meter ruler. Okay, using a ruler. So use the height, therefore, at a certain height. Okay. And then we have the cupcakes there. Okay, that's the first one. Now, what else do we need to do? What else do we need to do? So one we have, okay, so measure the height using the ruler. Okay, so we start with one cupcake. Okay, so release it at that height. Okay, and then, okay, so release it at that height. So start stopwatch. Okay, all right, then stop stopwatch as soon as the cupcake hits the ground. Okay, right, and this is how we get the time. So this gives us the time taken. Okay, so now we've said how to get the time taken. So we're going to have stopwatch, and this will fall down. So we start at the top and then we end at this at the end. So this will give us time taken. Okay, right, and then I'm going to do number 5 using equation number 1. So equation number 1 to calculate speed. Okay, and then number 6, what we're going to do, number 6 is we're going to repeat the steps 1 to 5, okay, with different number. So this is number of cupcakes. Of cupcake cases. Yes, cases, yeah. So cases there. Let me take a look. Cupcake cases. Alright, so cupcake cases. And then we add more as we go along. Yeah? There's more going on. And then number 7, if we want to do that. So number 7, we've done that, we've repeated. Let's say we stop with 1, we want to 2 cupcake, 3 cupcake, 4 cupcake, 5 cupcakes, yeah. And then at the end we can also do, we can repeat. Okay, we can do a repeat, maybe let's say 3 times plus take an average. Okay, so what we've done, because we've done this all once for many cupcakes. Now we repeat it one more time again, and average. Okay, so this is what we can do. Again, so this is 4 marks. Now that should be enough to get you 4 marks there. Okay, now normally this could be like a 6 marker as well. Now here we go. Now the good thing with this question here is they've given you the equation. They're giving you the equation. Okay, now you need to calculate the weight. So the weight is mass times gravity. Mass is 0.005 times gravity 10. So the answer is 0.05 Newton, and this is the answer there. Done. Okay, nice and easy. This is like the easiest question in this one. Let's say one of the easiest question there, because you just multiply numbers together, use a calculator. Done. Okay, now the cupcake is falling at constant velocity. So constant velocity again. So not changing. The velocity is not changing. Now draw the air resistance. Now air resistance, we know is going to go up. So again, from the center here, goes up, and this is air resistance. Okay. Now the length of the arrow doesn't matter. So the length of the arrow does not matter. So if you're drawing bigger, it doesn't matter. Oh, wait a minute. Wait a minute, it is constant velocity, so yes, so it is constant velocity. Okay, it is constant velocity, then the forces need to be balanced out, isn't it? The forces need to be balanced out, so therefore it need to be roughly the same length. Here we go. Okay, so air resistance. Here we go. It need to be roughly the same length because it is a constant velocity. So constant velocity, okay, means no resultant force. Okay, falling constant velocity. Okay, so therefore forces equal to balance. Okay, now state the value of acceleration of the cupcake at constant velocity. Now, if the velocity is constant, so they have constant velocity, means that, so now remember, acceleration is change in velocity over time. Now, since the velocity is constant, okay, since the velocity is constant, this means that the change in velocity is zero. If the change in velocity is zero, then acceleration is change in velocity over time, and change in velocity is zero over time, so therefore it's zero. So therefore, acceleration is 0 meters per second squared. That is y is 0. Now you know y is 0. If you got this wrong, now you know y is 0. Now, here we go. Right. Blah, blah, blah. Speed, mass, useful energy. Okay. Now, what we have is we have the force. Now, what equation that has force in it that links these three together? So what I can remember work done is force multiplied by distance. We need to work out force. Force is work done divided by distance. The work done is the energy, which is this much, divided by 28. Okay, and then the energy is this. Okay, so therefore the answer is this much. There we go. For 3 marks. Now, this information here, So what they've done in this question is they give you more information than you need. Okay, and you may be confused with this, but what you need to understand is okay, what do I need? I need the force. Okay, what do I have? What equation are there that links these things together? Okay, now what equation have we learned that link speed and force together? I can't remember. What equation that links force and mass together? Now we learn about F is equal to ma, but this F is the resultant force, yeah? Well, and we're looking for the average force, so it can't be this one. So it has to be this one here. Okay. Alright. Resultant force. Okay, now also the reason why we can't use F equal to ma is because we don't know the acceleration. Okay, so we can't use this one. Average force, yeah, that's fine. Average force, fine. Now this one we need to remember. So GPE equal to mgh. We need to rearrange for h again. We need to be able to know how to rearrange stuff, guys. Okay, so this is 2 marks there. GP over mg. GP is 270 over m. What's the m? Oh, we don't know what m is. Oh yes, we do know. So the force is the Earth exerts the force of 150. So therefore, now look, 150 is pulling down. So this 150 is pulling down. So this is the weight. And weight is mg. And therefore, this is going to be this. And this will give me, let me use my calculator, check. 18. Okay, so 18 there. That's one. Now state the kinetic energy. Okay, now energy. We know one of the rule of energy is energy can be transferred. Energy transferred. So therefore energy transferred from GPE to kinetic energy. So therefore kinetic energy is going to be 2700. Okay, because this is what you have. Oh, work done. You can also use the work done equation. Okay, that's fine. We can also use the work done. Work done is force times distance. We're looking for the height, so distance equal to work done over force. Work done is 275 over the force is this one, and then this is distance is 18. Okay, so you can use 2 methods there. Okay, now What's the velocity? Now again, kinetic energy equation, we need to know that. Half v squared. So kinetic energy we know half times 15 times this. So 27 times 2. Again, when we get rid of the half, it becomes a 2. Okay, just one moment with me. Right, so we have 2. Again, because we're getting rid of this half, it goes 2. 15 multiplied by v squared. And 2 divided by 15 equal to v. And v squared equals to, okay, let me just do this in the calculator. 6, and this equal to square root of 36, and this equals 18.97. Okay, so we can run this up to 19 if you want. That's it. Okay, again, so look how we need to do it. All we know is because we know the kinetic energy. Okay, now if you don't know the kinetic energy, you know the height, of course, you know gravity. I think you can do that as well, but let's keep going. Now look at that, we have another question on GPE. So if we got this question right in terms of GPE, then you can do this one as well. GH 4.5 times 10 times 20. Okay, and we get 900. Now same thing here. Instead the useful energy work done, what happened is energy is transferred. Okay, from GPE to work done. So therefore this is also going to be 900. Now for those of you who got this wrong, this is the explanation. Why is it 900? Because energy is transferred from GPE to work done, and you need to know that. Make sure you have to write it down. So equation again, power is energy over time. Okay, energy is, we've calculated it, it is 900. From there, divided by time, which is 4 seconds, this will give me 225 for 2 marks. Okay, now let me go down. So here we have this guy on the ramp, the guy goes down. Again, let's talk about that. We've got GP on the top, so the guy goes down, so that's turned into kinetic energy. Okay, now there's going to be some friction there. So friction, there'll be heat, energy through friction. Okay, now what is X represents? Now X is the wasted energy. So this is wasted energy, and this will be in the form of thermal / heat. Okay, mainly heat, yeah, mainly heat. Sound, a little bit of sound, because mainly heat in this case. Why is it heat? Because it tells us that it goes down the ramp eventually. Now calculate the X. Now X we know, let's have a look. The total energy equal to useful plus waste. Now the total is 980. Useful is 95 plus waste is we don't know. So therefore waste is 980, take away 95, and this equal to 30. Okay, again, for those who got this wrong, make sure that you know how to work this out. Now efficiency equation is useful over total. Useful is 950 divided by total is 980. The total, look, the total is always the one that goes in. The useful is always on the right, and the waste is always down. Okay, and then this will give me 0.95 or 97%. Okay, so either way, it doesn't matter. Whichever way you want to write down, this one doesn't matter. Now here we have the wheels. Okay, let's do the wheels again. So we have, what do we have? We have large wheels, move the chain. So we've got large gear, Ratio, again, we need to do the ratio, yeah? Ratio. Then we have small gear. Okay, now the large one is 480, not 40, 48, and then go 12. So the ratio is going to be 1 is to 4. So we know the questions talk about the small gear. So we know that the large one turns 2 times each second. Okay, so we know that small gear equal to faster, and we know it's going to turn faster by 4 times. Okay, so therefore it's going to turn faster by 4 times. Now if the large one is turning 2 times, okay, so 4 times 4 times more, 4 times more. So if the larger one is turning 2 times every second, so therefore the small gear would turn 4 times more. So therefore it's going to be 2 multiplied by that 4 times. So this will give us 8, and this will be 8 turns per second. Again, if you got this wrong, hit the working out. Good. Now, what is this going on? Now, this is a good question there. Oil. Now, oil, okay, what does it do? Okay, so oil provides lubrication. And what does it do? It reduces friction. Okay, now, if friction is being reduced, what does this mean? Okay, this means that less energy transferred as heat. So therefore, less wasted energy. Now, if there's less wasted energy, what does this mean? It means that there's more useful energy available. Okay, now if there's more useful energy available, okay, now efficiency, okay, is useful over total. So therefore, more efficiency. Okay, now we need to explain. So what I've done here is I've broken it down into a flow chart. Why? So we know why. The question tell us why having oil improve the efficiency. Okay, and you see that I end up my flow chart with saying, oh, there's more efficiency. Why do we have more? Why do we have more efficiency? Because the oil provides lubrication, which reduces friction, which means there's less energy transferred as heat. Therefore, there's less energy wasted. If there's less energy wasted, it means there's more energy useful. And energy useful is dependent on efficiency, because efficiency is useful over total. So therefore, if there's more useful, it means there's more efficiency, full stop. This is where we get to the conclusion, yeah? Okay? So we need to be careful of that, the way how we phrase stuff. Okay, and then we have question 8, which is the spring there, very, very nice. Alright, question 8, we have about moments. Okay, now we have all this thing going on, but we need to read the question to know what we are going to be looking for. Okay, now we need to, the moment about C, first of all, this is C, is this much. Calculate the weight of C. Okay, fair enough. Now the weight, we know that weight is a force. So therefore, it is just F. So I can rearrange this. F equals moment divided by the distance. The moment we know is 0.6. Now, remember, this is in Newton meter. So therefore, what is the distance? Now, C is this far from the pivot. Therefore, we got, so 10, 20, 30. So it's 30 meters, sorry, 30 centimeters away. Now, how do we know this is centimeters? The question tells us it is a meter rule. If it's a meter rule, means from here all the way down to here, this is a 1 meter. So therefore, these have to be centimeters. So therefore, we need to 30 centimeters. This needs to be converted into 0.3 meters. So we need to convert this into 0.3 meters. Therefore, this is 0.3 meters, and the answer is pretty much 6 divided by 3. The answer is 2. So therefore, the weight of C is 2. Next, we need to show that the total moment of S and R is this. About P, which is the pivot, is this much. So therefore, what we need to work out is 1. We need to work out moment of S. Okay, so let's work out the moment of S. Moment of S is F times D. Now F is going to be S, so S is 2 Newton multiplied by D. How far is S from the pivot? S is 10 centimeters. Okay, so 10 centimeters, which is 2 times 0.1, so this will be 0.2 Newton meter. And then we do the same thing with 2. So moment of R is F multiplied by D. F of R we know is going to be 1 multiplied by the distance of R. So R is all the way from here all the way here. So it's 1, 2, 3, 4, 5. So it's multiplied by 50 centimeters, which is 1 multiplied by 0.5 meters. So this will be 0.5 meters. So therefore, the total moment is 0.5 plus 0.2, 0.7 Newton meter, and this is how we showed it. Now it's 2 marks. We need to work this out, we need to work this out, and then we need to do the maths. Nice one. Question says, okay, so is it in equilibrium? Okay, now first of all, we need to remember. Okay, so first point. So the principle, I'm going to zoom in now. Okay, let me try to zoom in again. Okay, the principle of movement. Tell us, okay, for objects to be balanced or in equilibrium, the total anti-clockwise moment must equal to the total clockwise moment. Okay, so therefore, what we can do here, we can look at the numbers. We can say the total anti-clockwise moment, so in this case going to be C. Okay, so moment of C is equal to 0.6 Newton meter. Okay, and then moment of S and R equal to 0. Newton. Okay, now they are not equal. You can see that the moment of C, so the moment on the left hand side, is 0.6. How do we know 0.6? It's written there, 0.6. And the moment, so this here, to the left, let me just write it down somewhere. So all this here is 0.6, and all this here, with these two together, is 0.7. As you can see, they are not balanced, so we need to say they are not balanced. Okay, so therefore, if they're not balanced, we can say the toy is not in equilibrium. Now, 3 marks. The first mark you get if you mention about this here. The first 2 marks you get if you mention this. Okay, and then if you mention this. Okay, so this should be enough to get you your 2 marks. Now, the last mark, whether if you say this statement here, this statement is only valid if you say the other statements. Yeah. The last statement again is only valid if you mention the other statements. Okay. Now, right, let's take a look. Forces at a distance. So this here is non-contact force. So for example, of a non-contact force, now gravitational. Okay, it's already taken. Not gravitational. What are the forces we have? We have magnetic force. Okay, so that's the force. Now, magnetic force. Okay, so between north and wait, between north and south poles. North and north. Okay, let's say between magnetic poles. Magnetic poles. Okay, so that's one. That's it. You get 2 marks. 1 mark you get for mentioning the force, and second mark you mention between what kind of object. So here we've got magnetic poles. The poles, the north poles, south, the north and north, south and south. Okay, that's one. Now I'll also mention another example. So non-contact force. So we have electrostatic force, and this is between charged particles. Okay, so for example, if you have positive and negative electrons, electrons, proton, and so on. Okay. All right. So here we have four. Okay, 4 blades. Four force goes up. Okay. Okay. So on. Okay. Now let's take what we got. State the relation. Explain the relationship. Blah blah blah, and so on and so forth. Okay. Now relationship there. Now look at this graph. Okay. Now what can we say about this graph? Look at the graph carefully. What can be said? Okay, now the first statement we can say, okay, so what's the relationship between force and speed? Okay, so here I can say that the upward force increases, okay, with speed. Okay, so as the force increases, as I go from 10 to 30, what's happening? The speed goes from 4,000 all the way to this here. You can see that when one goes up, the other one goes up. Okay. Now the next one is how is it increasing? Okay, how is it increasing? Okay, so it increases. Okay, so what kind of graph is this? This is an exponential graph. So it increases exponentially. Exponentially. Okay, and I can also say they increases pretty much in a non-linear way. Non-linear way. Okay, because it is not straight. Look at that. This is not a straight graph. This is not. I'll write down not directly proportional. Okay, so this is not directly proportional because it's not a straight line graph, and also when one goes up, then one doesn't go up by the same amount. Okay. Now, and the last one, here we go. Now, this is a good one. We need to mention 2 things. Friction. Now, friction, for those of you who got this wrong, friction, it opposes. It is the force that opposes motion. Okay, now let's take a look. Where is it going? It is going down. So look at this. It's going down the slope. So therefore, friction will be against that. So friction is going to be against that. Okay. Now, what I will do is friction opposes motion. Okay, and it is a contact force. It means they need to have contact. So therefore, I'll start from the middle point here. Okay, and friction will be here. This is friction. Okay, again, for those who got this wrong, it needs to be on the surface. So this here is friction. Okay. Now, normal contact force, the word is normal. So normal means, so normal equal to perpendicular. And it tells you it is contact. Okay. So what happens is every time you're touching the ground, there's always normal contact force there. And the normal contact force, it is normal to the surface. Okay, it is normal perpendicular to the surface. Again, for those of you who got this wrong, make sure that you get this correct. Now, I need to draw a line from the surface in the middle all the way up. Okay, like this. and this is perpendicular, and this is the normal contact force. Again, okay, so this is normal contact force. It's always perpendicular. Now, for example, let me do one example here. So let's say I have in the corner, let's say I have the ground. Let's say someone is standing on the ground. Okay, so here the normal contact force will be from the ground if the guy's pushing the ground. Let's say, let me just change this back to the same color. Let's say the guy is on the ground. Okay, like this. So normal contact force would be from the ground pushing up. So this is normal contact force. Okay, so always perpendicular to the surface. Now 3 marks. You get the marks for making sure that the arrows are labeled correctly. You get the marks for if they are in the right direction, and the friction arrow is labeled with friction. The normal contact force arrow is labeled with normal contact force. They're pointing in the in the correct direction. Okay, so label correct, and then same direction in this case. Okay, again, so make sure everything is properly. If you got this incorrect, so look at all the annotation there to make sure that we get it right in the next time. Now look at that. Look at all the annotation. If I go back, look at that. All the annotation bullet points. Okay, if you've got this wrong, it's 2 marks. Look at that. 1, 2, and 3. And look, the 2 points: rearrange, substitution, calculation. And look at this one: 3 marks. The flow chart I've done. And there were 2 marks: the ratio and how to get the answer. The equation, how to get 30 for 1 mark. Equation we need to remember. Substitution, again, if you got all this incorrect, you need to see that now you have the equation down, so we need to make sure that our power pen is done properly, yeah? Okay, because this stuff we need to know. We'll come again next year and for year 11 as well. So all these stuff, all the basic stuff. So this is like basic foundation stuff, yeah? Okay, so make sure that you do get the foundation properly. So again, acceleration from the gradient. How do you work out gradient? It's there. Distance, all these things. Make sure we are on point there. Okay. Again, so these are, remember, full ball pen, full explanation, full calculation, and make sure that you are indeed awake.